Hello guys, again, this is your teacher, Rodolfo Eric Angat. So today we'll be discovering about the movement of lithospheric plates. So let's begin by identifying the different layers of our planet. The outermost layer of our planet is the crust. So this is where we are. While underneath the crust, we have the mantle, wherein we have the upper mantle and the lower mantle. This area here is like plastic. So it's moving. It's like semi-solid or semi-liquid. It has the plastic properties that allows it to move. And convection is happening in this area here. As we go deeper inside Earth, we reach the liquid iron and nickel. So this one is liquid. This layer is known as the outer core. Again, this layer is known as the outer core. The center of our planet is believed to be solid, which we call the inner core. The inner core is solid because of the immense pressure brought upon by the layers above it. So even though that this area here, the inner core, is the hottest, it remains solid because of all the pressure that prevents it from melting. Now, this one here, the outer core, is liquid, and the swirling metal in this outer core is the one that gives us or that gives our planet its magnetic field. Remember in our last lesson, the magnetic field protects us from the radiation from space. And then we go back to the one above the outer core, the mantle. Convection currents happen in the mantle that affects the characteristics of the Earth's crust. There are two types of Earth's crust. We have the continental crust, like the continents, like the United States is in North America, like Asia, like Africa. Those are continents, and they are made up of the continental crust. The second type of Earth's crust is called the oceanic crust. The oceanic crust is Earth's surface at the bottom of the ocean. Underneath the crust, we have the upper mantle that includes the asthenosphere right here, and then we have the lower mantle right here. In some references, the crusts are also known as tectonic plates. So we can also say that this is continental plate and this is oceanic plate. One thing that you have to remember about this crust or these plates is that though the continental crust is thicker than the oceanic crust, the oceanic crust is denser than the continental crust. Again, I will repeat that. The continental crust is thicker than the oceanic crust, but the oceanic crust is denser than the continental crust. During the time of Alfred Wegener, he proposed the continental drift theory, and he explained that continents are drifting apart or they're moving. They're moving apart. He used evidences like similarities in rocks and fossils in the edges of the continents and many other evidences that he presented. But he did not answer one question that led him to fail in his endeavor to make the scientists back then or the intellects back then to believe his theory. The question that was asked to him was, what power can move the continents? And he could not answer that because technology was not yet that good during that time. But during World War II, many innovations were invented, and it was discovered in the Atlantic Ocean by Harry Hess that there is this place which is now called the mid-ocean ridge, which runs across the Atlantic Ocean. It was observed, or it was discovered, that the Atlantic Ocean is spreading apart and that new materials are added. And further investigation revealed that the tectonic plates are moving because of the convection currents in the mantle. The convection currents in the mantle act like wheels that draw the tectonic plates or the Earth's crust towards or away from each other. Like, look at this wheel here. This is convection current. Hot material goes up, cooler material goes down. Look at the direction of this convection current here. Hot material goes up, cooler material goes down, pushing the tectonic plate or the crust to that direction. Look at the way that this convection current spins. Hot material goes up, cooler material goes down, so it moves there. If only Alfred Wegener had the resources to discover the convection currents in the mantle, he would not have been ridiculed during his time. But of course, nowadays, we treasure the discovery of Alfred Wegener, and we now have a better understanding on the continental drift theory that he presented. And now that theory is now included in the science of plate tectonics. If you have any question, again, please ask during our class and continue learning. Thank you so much.